voltage source is connected to a resistor. Resistor is connected to diode. Okay. This is a very simple circuit. So supply voltage is E. This is R. This is D. Okay. And let us assume the voltage drop across the diode is VF or VD also you can take, no problem. And now tell me the diode is forward biased or reverse biased?
Forward biased.
Forward biased. So current will flow. So current is flowing in this loop. So let the current is IF. Okay. Now apply KVL in the loop. What will get? E minus to plus. This is minus. This is plus. So I'm moving from minus to plus. So E. Then this is plus minus. Current is flowing from plus to minus. So minus IF into R minus VF equals to 0. Okay. So E equals to IFR plus VF. So how much voltage I am applying? That is drop across the diode plus drop across the resistor. That's a very simple concept to know. Okay. Now from this equation, I want to find out what is the maximum voltage in the circuit and what is the maximum current in the circuit. Okay. So for that, what I'll do, I'll take the condition. If no current is flowing in the circuit, that means IF is 0. So if IF is 0, then what is VF? Tell me from this equation. Let's say this is equation 1. In equation 1, if I put IF 0, then VF equals to what?
So
E. That means supply voltage. Now, if VF is 0, that means drop across the diode is 0. Then what is my I?
sir, E by R.
E by R. Now let us take some numbers so that it will be more clear. Let us take E equals to 5 volt, R equals to 100 ohm, and diode is ideal diode to take. So if I take that one, then VF equals to 5 volt and IF equals to 5 by 100. That means 50 milliampere. Clear? Is it clear?
Yes,
So
sir.
if current is 0, I am getting maximum voltage as 5 volt. If voltage is 0, drop across the diode is 0, then I am getting maximum current of 50 milliampere. Can I get more current from this 50 milliampere in this circuit? 60 or 70 or more than 50 milliampere can I get? If E is fixed and R is fixed as 100 ohm, can I get more than 50 milliampere current here? तो ज्यादा करंट मिलेगा यहाँ पे? If E is fixed as 5 volt and resistance is 100 ohm, can I get more than 50 milliampere current in the circuit? Yes or no?
So can you repeat the question?
if I am fixing E as 5 volt, okay, and R is 100 ohm, can I get more than 50 milliampere current?
No, sir.
If V equals to 0.
No, sir.
Yes or no?
No, sir.
No, because already the voltage is fixed and resistance is fixed. So always I'll get IF equals to E by R. So 5 by 100 means maximum 50 milliampere current we are getting. Similarly, if current is not flowing, can I get VF more than 5 volt? Obviously no, because maximum voltage I'm applying 5 volt means the drop will be 5 volt. So in this circuit, what I have shown, maximum current and maximum voltage I have calculated. Okay. Now I'll draw the characteristic here. You see, I'm plotting a graph where VF, that means diode voltage versus diode current. Okay, I'm taking this is 0, 1, 2, 3, 4, 5, 6, 7. Similarly here, 10 milliampere, 20, 30, 40, 50, 60. Okay, so I have found out the condition maximum current and maximum voltage of this circuit. Then I'm plotting a graph between voltage and current. Now what I have understood here, maximum voltage in my circuit will be 5 volt and maximum current is 50 milliampere. So more than 50 milliampere I will not get, more than 5 volt I will not get. So I'll join these 2 points. Okay, so I'm getting a straight line here. So this straight line is called load line. Okay, so the point joining maximum voltage and maximum current of the circuit keeps a straight line which is called as load line. Is it clear? Or in fact it is also called as DC load line because DC voltage we have connected. So DC load line you can say. So the DC load line is a straight line that gives all the DC condition that could exist in the circuit. That could exist means 0, 10, 20, 30, 40, 50 milliampere. So maximum current we have taken as 50 milliampere. Here also if you consider the voltage 0 to 5 volt, so we have taken the maximum voltage. So any condition within the circuit can be represented by this. And this is called as load line because you see here this current is dependent on what? R. R is your load resistance. If I'll increase the R, then IF will decrease. Yes or no? By keeping E constant 5 volt, if I increase the resistance 100 to 200 ohm, then obviously current will decrease. Do you agree or not?
Yes, sir.
Similarly, if resistance will decrease, then current will increase.
Yes, sir.
Now, this is my current point. So this point may shift downward or upward depend upon the R. Yes or no? This 50 milliampere we are getting, if resistance value will change, then IF will change. IF will change means this point, 50 milliampere point will change. So this is changing means I may get like this graph or this straight line, or I may get this type of straight line. Yes or no?
Yes, sir.
Now This is changing means what is changing? The slope of the line is changing. If I take this one and this one and this one, what is the difference? The slope of the line is changing. So the slope of the line is depend on what parameter? Resistance value or not? Yes or no? The slope of the line is depend on what? This resistance value. If I am changing the resistance, the slope of the line is changing. So that's why it is called as load line, because this line slope is depend upon the load resistance value. That's why it is called as load line. Is it clear what is load line?
Yes, sir.
Now load line gives you the maximum current and maximum voltage, and within the circuit whatever the voltage and current we are getting. Now this is the circuit. Okay, now inside the circuit what is there? One voltage source is present, one resistance, load resistance is present, and one diode is present. Now circuit condition we have found out, but diode having different characteristic. PN junction diode we have already studied in the first module. And what is the characteristic or current or voltage characteristic? Up to 0.7 very less current, after 0.7 the current is increases exponentially. So if I plot the current voltage current characteristic of diode inside this, then how it will be? Like this. Yes or no? This is the diode characteristic. So first I have found out the circuit condition, and second I have found out the component which is present inside the circuit. Its characteristic is a little bit different, right? Now at how many points they are crossing? The load line and diode characteristic are meeting at what point, or how many point of intersection we are getting? 1 point. Now if I take this point somewhat here, see what is the current and what is the voltage value? Tell me. The intersection point, nearly about
Current 40
milliampere, voltage is,
and voltage 1 volt.
now what equation we have got earlier? E equals to IFR plus VF. Okay, this equation, the base equation we have found out. Now if I take this one, E equals to IFR plus VF. If this is satisfying, KVL is satisfied. What I have taken? E equals to 5 volt. IF what I am getting here? 40 milliampere into resistance 100 ohm plus 1. So 40 milliampere into 100 means 4 volt plus 1 volt is equals to 5 volt. So it is satisfying the condition, or KVL is satisfied. Yes or no?
Yes, sir.
So KVL is satisfied means what? The circuit is stable. Whenever you take like KVL in a loop, voltage should be 0, or if you take KCL, incoming current is equals to outgoing current. That means what? That circuit is stable. If it is not satisfying that condition, then circuit is unstable. So here what we have found out, this point if I operate, ये क्या आ गया? Okay, so this point, when I operate my circuit at this point, that means 40 milliampere and 1 volt I am getting. at that condition the KVL is satisfied. That means my circuit is stable. Okay, so this point is called as stable point or quiescent point. That is also called as Q point or operating point. Different book have different name. So stable point, quiescent point, Q point, operating point. So all these are single point. Okay. Now you will say, sir, I can take this point. If you take this point, then you will get some current and some voltage, no doubt. But in this point, the diode characteristic is not satisfying. Like suppose you are going for a shopping. You are trying to purchase a dress. Okay, for you. Now, what is the most priority thing you will check? There are a lot of parameter when you go and purchase a dress, like color, brand, price, all these things. But out of that, what is the most priority thing? Size? Yes or no?
Yes, sir.
If it is not fitting to you, then whatever brand, whatever price, whatever thing, that is useless. So you see here, this red line is the load line, which is giving the maximum condition current or operating current and voltage of the circuit. But inside the circuit, one diode is there. Inside the circuit, the diode is there. So the circuit having different characteristic and diode having different characteristic. Whenever they are matching, then only the circuit will operate in a stable condition. So this red line is the circuit characteristic and this one is the diode characteristic. If they are fitting, then only it will operate at a stable condition. Like you can say these are this diode is U and this is your dress. So when they are matching or fitting, so this fitting point is this point. Only at this point they are fitting. That's why the circuit will operate stable or stable operation can be performed. Okay. Any other point it will not satisfy because it will so any other point it will not satisfy because it will not stable. Okay. So let me erase this thing. So this is the idea about the load line and Q point. Okay, so you can see this one. This circuit I have explained, and this one also explained. So this is your Q point, load line, diode characteristic, current and all. So you can see the definition of Q point. The intersection point between the DC load line and device characteristic is known as Q point. So why it is written device characteristic? Because the example what I have given, diode is used. Instead of diode, you can also use transistor or BJT, FET, okay, MOSFET. So depend upon circuit, the component will change. So the reason is that the intersection between the component characteristic as well as the load line gives you the stable point or quiescent point. So this is the only point on the DC load line where diode voltage and current are compatible with the circuit condition. Compatible means it is satisfying the KVL. Okay, so 40 milliampere 1 volt. So just now we have seen it is giving you the 5 volt. So though we take VF is 0 to 5 for plotting the load line, but it will not possibly practically possible. So only one condition is satisfying. So that will giving the operating point or operating or stable point or Q point. Okay, any doubt from this? What is load line? How to find out load line? What is Q point? Anywhere you have not understood, just ask me, because I'll go for transistor circuit. Okay, very simple. I have taken a simple circuit. I have found KVL. Then what is the maximum current? What is the maximum voltage? I have found out. Then plot the load line. Why it is called as load line? These are all short questions. Okay, what is load line? Why the load line is named like so? What is Q point? Okay, all these things. Then what is the importance of Q point? Now we'll go for transistor characteristics. So out of this common emitter, common base and common collector, which configuration is more preferred?
The common emitter.
Common emitter. So we'll discuss common emitter circuit here. So let us first draw a common emitter circuit. So common emitter means first you have to take the transistor like this and orient the transistor so that emitter terminal at bottom, and PNP transistor I am taking here. Then we'll connect one resistor here and connect another resistor here. Now this is your P, N, P, emitter, base, collector. Okay. Now base and emitter should be forward bias or reverse bias? Emitter base junction should be forward bias or reverse bias? बहुत बार बोल चुका हूँ, तुम ऐसे भूलोगे तो कैसे होगा? Emitter base junction should be always forward biased. Collector base junction should be reverse biased. How many times I'll tell? So emitter base junction should be forward biased means N will be connected to negative, P will be connected to positive. So let us take this is V, BB. Similarly, okay. Now what is the voltage here between base and emitter? VEB. Between collector and emitter, VEC. Okay. Now current, how current is moving? This is your emitter current, base current, collector current. So collector current is flowing like this. So this is plus, this is minus. Now apply KVL here. In this loop you apply KVL in the output side. So if you apply KVL, what I'll get? Plus to minus, minus VCC, then minus to plus ICRC, then minus plus, so plus PEC equals to 0. Okay. Now if I find VEC equals to VCC minus ICRC. So like diode equation, I have found a equation here. Okay. Now you compare the previous equation and this one. Here I have found out supply voltage equals to this and drop across the diode. Here what I have done, drop across the diode, that is diode means here transistor we have taken, so output voltage VEC equals to supply voltage minus drop across the resistor. Now if I want to find out what is the maximum voltage and maximum current, what I will take? Same condition I will apply. If IC equals to 0, tell me, if IC equals to 0, then VEC equals to what? Put IC 0 in this equation, above equation. Let us take this is equation 1. What is VEC?
VCC.
VCC. Now, if VEC equals to 0, what is my current? IC. V is equals to 0. What is IC?
VCC by RC.
VCC by RC. Okay. Now you compare these two with previous one. So this is like here also we are getting E equals to VF equals to E. That means drop across the diode is equals to supply voltage and current equals to supply by resistance. So here also same thing we are getting. VEC, drop across the transistor output voltage equals to supply voltage and IC equals to supply divided by RC. Yes or no?
Yes, sir.
Now I have taken output side, so I'll plot the output characteristic of transistor. So before that, just put the x-axis and y-axis. So in x-axis, what I'll take? Output voltage VEC and what is my output current? IC. Okay, this is 0. Now what I have found out, maximum voltage VEC equals to VCC and IC equals to VCC by RC. That I will mark. So if I take 1, 2, 3, 4, 5, 6, 7. So somewhere let us take this is my VCC. Okay, and here 10, 20, 30, 40 you take, and let us take somewhere here is my VCC by RC. Okay, so this is your IC and this is your VEC, that is VCC. Okay, so VEC equals to VCC, IC equals to VCC by RC. So I have marked it. Then I will draw the line. So this line is called as what? Like diode characteristic we have seen. Here this line will be called as क्या बोलेंगे? ये क्या लाइन अभी बोला था? The line, the line which is joining the maximum current, maximum voltage, that is load line. Okay. Now, in this circuit, diode is the component. Okay, so that's why after drawing the load line, I have drawn the diode characteristic. Tell me, in this circuit, what is my component? Diode or transistor?
Transistor.
Transistor. Already I have drawn the load line. Then what type of characteristic I will draw? Transistor characteristic. So if I draw the transistor characteristic like this, we have seen the output characteristic for common emitter configuration. Okay, so this is your IB 0 microampere. This thing already we have discussed. Okay, if you try to refresh, this one. Okay, for different IB, VEC versus IC, that I am actually plotting. Okay, so this is already have done in the lab also. 10 microampere IB, 20 microampere IB, 30 microampere IB 40 microampere, IB 50 microampere. Okay. Now, once I do that, I'll take the Q point. So this is my Q point, Q point, Q point, Q point, Q point, Q point. So I'll name as Q1, Q2, Q3, Q4, Q5, Q6. Okay. Understood? Load line and Q point. Now I have drawn here 6 Q point, but at a time only 1 Q point will get, because for each IB we are getting the characteristic. I cannot get IB 20 and 30 at a time. So at a time only IB 20 or 30 I'll get. So if you operate the transistor at a time, only one characteristic I'll get. But because these are the conditions, or different IB and different IC will get, so at a time all the graphs are shown. But practically, if you operate the transistor, only one characteristic will get, that is IB 10, 20, 30, 40 or 50, anything. Okay. Now, see how the transistor amplification will happen. Here, so out of this, all these characteristics, suppose I want to fix IB to 30 microampere. Okay, IB to 30 microampere. So for that, I need to apply some voltage VBB, and I have to connect some resistance. Yes or no? Some value I should give, some 5 volt, 10 volt, or whatever. After calculation only that can be confirmed. But you have to fix some voltage, you have to fix some resistance. Okay, then only 30 microampere current will flow. Let us assume I have taken some voltage and I have taken some resistance, so that I have fixed my IB to 30 microampere. Tell me, this is DC current or AC current? In this circuit, have I applied any AC?
No, sir.
No. So this is your DC current. But amplification means I want to amplify AC signal. So what I'll do, once this is fixed, IB is 30 microampere fixed, I'll connect one AC source here. So this is written as small IB to represent AC, and this AC which is included here, I'm representing here within AC line. Okay, so let us take, this is your peak to peak, 20 microampere, 10 upper, 10 niche 10. Okay, so IB equals to 20 microampere, right? AC, already I have given DC. After that I am adding AC. So input to the circuit will be DC plus AC. This is the input. Now this is my output side. So output, what I'll get? I'll get AC plus DC. So DC is capital IC, AC is small IC. So this is my output line. So I'll extend this one here, I'll extend here, and this is the center line. So from here to here, here DC, and here to here I'm getting AC signal. Okay, suppose I'm taking here, this is 10, 20, 30, 40, 50, 60, like this. Then what is my AC current I'm getting? Tell me. From here to here, how much we are getting? 30 minimum, 50 maximum. तो peak to peak कितना होगा? The minimum voltage is 30, maximum is 50. What is the peak to peak voltage? Are you able to hear or not?
Yes, sir, we can hear you.
Tell me, what is the peak to peak voltage? Peak to peak voltage calculation also you don't know. This is 5, this is -5, this is 0. So what is the peak to peak voltage from here to here?
10.
Then here it is in terms of current, then we are not telling. This is 50 milliampere, this is 30 milliampere. What is the peak to peak current?
Say 80.
80.
No, sir, 20. No.
How you have calculated? You are telling this is 10. This is 10 or not?
Yes, sir.
How you have calculated this 10?
Sir, 5 minus of -5.
Positive peak minus negative peak. 5 minus of -5, that is 10. So instead of that, it is in current. This is 50 milliampere, bottom is 30 milliampere. What is the peak to peak current?
20.
Taking these are the very simple standard concept. If you are not able to tell this one, then how can I help you? So input what I am giving 20 microampere, output what I am getting 20 milliampere. Okay, it's a small IC. So this is amplified or not? Input 20 microampere, output 20 milliampere. So gain is output by input. So 20 milliampere by 20 microampere. What is the gain? जल्दी बोलो. मिली माइक्रो ये सब
0.001.
0.001 कैसे होगा? तुम कितना होगा बोलो?
Sorry, sir,
10 to
1000.
the power 3.
10 to the power 3 means 1000 gain.
1000.
So input to output is increased by 1000 times. Okay, so this is how the amplification is done. So current is amplified here. Input I am giving small AC signal whose variation is or peak to peak is 20 microampere. At the output I am getting 20 milliampere current. This is for an example I am telling. Okay, so gain we are getting 1000. Okay, so whatever input I am giving 1000 times it is increased. So what is my point here? I should operate the transistor at the Q point or stable point. When I have fixed this IB to 30 microampere, then I am getting the Q point as Q3 and I'll operate my transistor so that I'm giving the input and I'm getting the output, which is amplified version of input. Okay. Now, there are two type of things. Amplification means whenever I say amplified, the signal is amplified, the amplitude of the signal will increase. Okay, suppose I will take one signal is like this. Amplified means it should amplify like this. The amplitude of the signal should increase, but the frequency, you see here the time period is constant here for input and output. That means frequency should not change. Okay, and this type of output if you get, then you can say this is amplified output. Okay, again this amplified output is two type of things you can see. Suppose sometime I'll get output like this, some clipping happens. Okay, negative side or positive side. If this type of thing you'll get at the output, no doubt the amplitude is increased, but some portion of the signal is clipped. Okay, so this type of amplification is called as unfaithful amplification. Okay, so that they will not get proper output, some distortion will happen. Okay, so we always want faithful amplification for proper output. So always we want the signal input and signal output must be same. Okay, whatever signal, whatever amplifier I'll design, it should give you the proper output which is same as the, or the signal shape should be restored or same. You see here input and output signal shape is same. But if you clip from positive side or negative side, like suppose I'll clip like this, or like this, then it is not proper. This is called as unfaithful amplification. Now come to in this graph. Suppose I'll take the input signal here like this, and this is output here, and I'm getting the output amplified version like this. But after this is clipped because minimum point is 0, so I'm getting a clipped output. Or if I take the signal at this point, okay, and I'm getting the output somewhere here like this, and you see what is the maximum current I'm getting. This is my maximum current, so beyond this the signal will be clipped. So if I ask you, this is signal 1, this is signal 2, this is signal 3, tell me which is faithful amplification and which is unfaithful amplification. Out of 1, 2, 3, signal is amplified, but which one is faithful amplification, which one is unfaithful amplification? Come on, response.
Sir, can you please once again?
What?
Sir, the question, sir, can you please tell it once again?
I have marked here 1, 2, 3, na? All three are output signal. Okay, so out of these three, which one is faithful amplification, which one is unfaithful amplification?
First one is faithful.
Yes, first one is faithful, second and third
Unfaithful.
unfaithful, because some portion of the signal is clipping bottom side, because this is the minimum point, and beyond this minimum point I'm getting some signal, so it will be clipped. Similarly, this is my maximum current, VCC by RC, so whatever current I am getting beyond that, this will be clipped, so I am getting some clipped, positive clipped output here, negative clipped output. So these are the unfaithful amplification. So why that happens? Out of this 6 Q point, Q1 to Q6, when I have chosen the middle of the Q point as my operating point and I have added input signal, then my input signal is fine, amplified. But if I take extreme upper side or lower side, then maybe some portion of the signal clipped. Okay, so out of this 6 Q point, which one you should choose for proper amplification? If I ask, what will be your answer? Because already 6 Q points are there, Q1 to Q6. Which Q point you should choose so that proper amplification or faithful amplification will get? अरे समझ में आ रहा है कि नहीं? I can choose Q1, I can choose Q2, I can choose Q3, I can choose Q4, I can choose Q5, I can choose Q6. So I have already chosen Q6, Q1 and Q4 for example. So here we have seen unfaithful amplification, here we have seen unfaithful amplification. But here Q4 I have seen faithful amplification. Okay. So what is the most appropriate Q point so that your amplification will be good or faithful amplification will get?
Third.
Third or fourth, okay, because even if I'll take Q2 or Q5, maybe some portion may be clip if the gain is high. So always it is better to choose the middle of the load line. You see, this part and this part. So if you consider this middle area, wherever it is crossing the load line, then I can get most appropriate amplification. Okay, so this is a short question. Generally you will get where should the Q point so that the proper amplification will be done. So what is your answer? Middle of the load line. Okay, so Q point should be chosen at the middle of the load line so that proper amplification can be done. Up to this clear? What is load line, what is Q point, how we do faithful amplification, and where we should choose the Q point. Now to choose Q point, suppose I'll choose Q4. For that I have to set the IB 30 microampere. For IB to set 30 microampere, I have to choose proper resistance and proper voltage. Okay, so this process is called as biasing. So biasing means proper choosing of voltage, proper choosing of resistance, so that the transistor will bias, and a transistor will bias in which region? Can you tell me which region I am operating? Cutoff or active or saturation region? This is what region? Cutoff or active or saturation?
Sir, active.
Active region. So I should choose proper voltage and resistance so that my transistor will operate at the active region, and Q point should be at the middle of the load line. Okay, understood? What is biasing? Biasing is the proper choosing of resistance and voltage so that the transistor should operate in active region and Q point should be at the middle of the load line. Okay, so that is your biasing. So once you bias that one, then my transistor will operate and I can get amplified output. But once you fix, means already you have fixed IB to 30 microampere, but even after that, the current or the Q point may shift upward or downward. Suppose you have fixed the Q point as Q4, and once the transistor is operating and amplified, then slowly you will see the Q point is shift to Q5 or Q3. That may also happen. So tomorrow, because already it is 12:56, so tomorrow we'll discuss why the Q point will shift upward or downward, or what is the solution for that, or what is the problem for that, and what is the solution for that, we'll discuss. Okay,
Okay, sir.
so okay, tomorrow we'll discuss this point is located in the middle of the load line, so what we have discussed here. So tomorrow we'll complete this one with fixed bias circuit. Just a minute, I'll take the attendance, then we'll leave.